Hi, my name is Sahdev Zala. I am an open source developer at IBM and I contribute to Kubernetes. I am a co-chair of this project called Provider IBM Cloud, which is a sub-project of the Kubernetes Cloud Provider special interest group. And I'm also one of the maintainers for the HD project. Khalid, would you like to introduce
Sure.
yourself, please?
I'm Khalid Ahmed, and I'm also a co-lead on the provider for the IBM Cloud. And I also work on IBM's Kubernetes and multi-cloud management offerings and in the open source community and ecosystem projects related to it.
All right, thank you, Khalid. All right, so welcome to this video. We have a few items in the agenda. We'll provide an overview of the SIG Cloud Provider, followed by this sub-project provider, IBM Clouds. We'll go through the structure, activities, and then we'll talk about cluster API provider, IBM Cloud, which is a GitHub repository owned by this project. I'll talk about the IBM Cloud Provider and what roadmap we have for the future there, and then we'll talk about the hybrid cloud ecosystem around IBM Cloud. All right, so the Cloud Provider Special Interest Group is one of the SIG in Kubernetes, and it does a lot of things actually. It owns the code around Cloud Provider interface and all the related work. As you may already know, there are specific control groups that comes, with Kubernetes to enable Kubernetes functionalities for, when you deploy on a particular cloud. And those control groups includes many different things, different interfaces to enable the load balancer, for the nodes to find out the IPs, zoning information. There are multiple interfaces, but the cloud but that repository that has the code for this cloud loops and interface, it's owned by Cloud Provider. There is a URL here. You can learn more there. The SIG also owns all the sub-projects. They were formerly known by individual cloud provider SIGs, like SIG AWS or SIG Azure or SIG GCP, SIG IBM Cloud, and similar way, SIG OpenStack, SIG VMware. But consolidation happened last year, and now all of them are, become a sub-project of the SIG Cloud Provider. So the SIG, IBM Cloud is now called a Provider IBM Cloud, and it's a sub-project of the Cloud Provider Special Interest Group. The SIG also ensures that the Kubernetes ecosystem is evolving in neutral to cloud provider ways, right? So it makes sure there's no favor for one cloud provider over other provider. And it also makes sure there's a consistent high quality user experience across different providers. Part of the SIG policy, when having chairs for the SIG, SIG makes sure there's only one chair from a single company. You can learn more about the Cloud Provider SIG in the GitHub repositories for the Kubernetes community. All right, so Provider IBM Cloud sub-project. The sub-project is basically around building, deploying, maintaining, supporting and using Kubernetes on IBM Cloud. We have IBM Cloud Kubernetes service as a managed service. We also have a Red Hat OpenShift as a managed service. And as you can expect, if you're participating in this sub-project, if you're a member of the mailing list there, you basically interact with many developers and leaders from IBM Cloud. And have these discussions around Kubernetes, around some of the other CNCF projects in an open platform. So you can follow the evaluations happening around the IBM Cloud platforms regards to Kubernetes and other CNCF projects. We do not use this platform, or this platform is not for any commercial discussions around any products. There are three colleagues: Khalid Ahmed, who is IBM Distinguished Engineer and one of the co-speaker here, represents Multicloud Manager and leads work there. Richard Thies, who is an expert on IKS and rocks, and myself from the open source side. If you're interested, please join the mailing list, to keep up to date with what's going on with this project. There is a provider IBM Cloud Slack channel on the Kubernetes Slack site, and you can learn more about the project at the provided URL. As far as activities are concerned, SIG meets every month with Slack channels, with emails, mailing list. We don't see a need to meet every week kind of things, which we used to have in the past. But now the SIG meets every month, last Wednesday, 2 p.m. Eastern time. If you're in different time zone, if you can, if you could not attend those meetings, then we record all those meetings and they are made available on the Kubernetes channel, so you can watch all the videos there. The SIG also participates while the subproject, which is the Provider IBM Cloud subproject, which is part of the SIG Cloud Provider. So obviously we participate in the SIG activities there. As far as upstream contributions are concerned, we have GitHub repositories called Cluster API Provider IBM Cloud. You may already know about the Cluster API project. It's a Kubernetes project, and the IBM Cloud API Provider, it's basically an implementation of this project, and it provides optional functionalities on top of the core Kubernetes around managing the lifecycle of Kubernetes cluster. Khalid will talk more on that. And then we are working on support for out-of-tree IBM Cloud Provider. I'll be talking about that right after I talk the managed offerings we have. So IKS, IBM Cloud Kubernetes Service, is one of the managed offering to create Kubernetes clusters. So IKS implements the IBM Cloud Provider to provide the functionalities when you as a user create a Kubernetes cluster using IKS. And as you may know, there's a conformance program in Kubernetes. So the IKS is a certified Kubernetes offering. You can read more about IKS on this URL provided right here on this slide. ROCs, Red Hat OpenShift from IBM Cloud, is another managed offering. OpenShift, as you may already know, it's a product that is built on top of Kubernetes and provides many additional features there. It is also a certified Kubernetes offering, and you can learn more about OpenShift on the IBM.com. All right, so the IBM Cloud Provider, there has been some discussions going on. So if you're following the discussions in the community around Cloud Provider SIG, you probably know that all those control loops I mentioned earlier, the code were part of the core Kubernetes. So they're part of the Kube Controller Manager and their architecture are called KCM. But the community realized that that is something needs to be decoupled from the core Kubernetes, so that the Kubernetes and Cloud Provider can evolve independently. So that code is the process still going on. Some of the providers already moved the code outside it, call out of free codes versus entry. But IBM Cloud Provider, we already have support for CCM. That's what we use now. As I mentioned earlier, right, there are multiple interfaces that Cloud Provider can implement. Not necessarily they have to implement all of them. Some of the bigger interfaces, right? There are more than this, but are load balancer, instances, zones, clusters, and routes. We implement the first three one, the load balancer. We have two offerings for the classic cloud infrastructure, the NLB version 1.0, IP table based, and the 2.0, which is IPVS based. Instances wise, instances v2 is it's a new interface which we'll be working to implement. And you know, we implement the zones, clusters, and routes. We have no need to implement them right now. For the routes, we use what Calico provides. For the future, you know, as I mentioned, there was, you know, in the initial days of Kubernetes, early versions, the code that enables the cloud provider functionalities, the control loops, they are part of the core Kubernetes. So at one point, the community decided to stop taking any new code there from any new cloud provider, and that's where we started exploring it. So we don't have code there. What we have is it's based on CCM. So they are pretty much ready for the out of tree implementation. So we will be open sourcing it, as we following what's going on there, and we'll be working on that. But on that line, along with that, we work on improving the documentations and align the builds, test and releases process with the community. There are discussions going on about making it more consistent across different cloud providers. So we will try to align with that as well. But with that, Khalid, I will hand it over to you.
Sure. Thank you, Sahdev. So I'll talk about a few projects that we're working on in the areas of hybrid cloud. And by hybrid, we mean not only the ability to run on-premise as well as various public clouds, but also hybrid in the sense that applications and workloads are, although the cloud native workloads run in Kubernetes, there are other workloads that a modern management plane, things like traditional VM workloads as well. So we're trying to bring some of those things together into a common management model based on Kubernetes. So one of the projects that is coming out in open source is around this multi-cluster management for Kubernetes. And this is a project we're partnering with Red Hat on. And Red Hat actually took some of the original code that was developed in IBM and is in the process of making that available as an open source project. It is currently there. If you look at this URL, a version of that allows you to deploy out and manage multiple Kubernetes clusters with a focus on the lifecycle management of OpenShift environments and being able to control and operate them, and deploy workloads on them, have the ability to search across Kubernetes clusters for resources, and also to handle some of the governance and risk aspects of the configuration of Kubernetes environments to make sure compliant with standards. So this product is available. The product for that is called the Red Hat Advanced Cluster Management for Kubernetes, and you can go and download and try it out in your environment. And it gives a base management plane for Kubernetes to deploy out and manage multiple Kubernetes environment. So if we can go to the next slide, one aspect of that is the policy management. And this is where both Red Hat and IBM are encouraging an ecosystem of contributions around how to manage and develop policies in a open but Kubernetes native model. I won't go through into all the details of the architecture and so on, but it is Kubernetes based. There's a YAML file that defines with the custom resource that defines your policy that can be checked into GitHub. And there's a way of deploying out policies from a central management hub to a set of Kubernetes managed clusters, and getting the reports of those policies in terms of the violations and so on that occurred back into the central management hub. And the types of policies, we can integrate with OPA. There's work that's also being looked at to integrate with other OPA related ecosystem projects like Gatekeeper and so on. But it is intended to be an open framework that allows different controllers to be defined and distribute out the policies to different locations and based on labels or controls, and gather the results. Okay, so this is a policy management extension that we're looking for people to participate in and drive some community around. Okay, so that's the multi-cluster management capabilities of around Kubernetes. If we switch to the next slide, I want to talk about another related project. This is about ManageIQ. Again, this is a totally open source project. The history of that was that it was based on an acquisition that Red Hat made, and it led to a product from Red Hat called CloudForms. But as part of the acquisition and relationship with Red Hat, this ManageIQ project is being kind of handled by IBM now, and it is part of an offering from IBM. I'll talk a bit about that later, right? But one of the new things about this project, so what ManageIQ does is allows you to manage traditional virtual environments, so things like VMware or KVM-based solutions. Kubernetes and Red Hat and so on manage container native virtualization. This allows you to bring in traditional workloads with traditional virtualization into a Kubernetes-based management model. So, the traditional ManageIQ deployment was on VMs. The latest iteration of that is a codified version of ManageIQ, where the ManageIQ control plane itself can run on Kubernetes, and we've made ManageIQ into a set of microservices that can be deployed within a Kubernetes environment. And it supports a variety of providers that I mentioned, right? It allows you to connect to a variety of cloud providers as well as on-premise, VMware traditional virtualization. It manages the infrastructure, the networking and storage, and brings that together. Okay, so this is another ecosystem project that helps the hybrid management aspect of the thing. So the open cluster management deals with Kubernetes and OpenShift. This project deals with traditional VM-based workloads and IaaS workloads within your cloud environment. The next chart. So Sahdev alluded to the cluster API project, and this is about the lifecycle management of individual clusters. And this is IBM contributes to that. We have a IBM Cloud plugin that allows you to declare how you want a cluster to be provisioned. And from a bootstrap node, you can provision multiple clusters, and it interacts with the infrastructure providers to provision the appropriate infrastructure resources and connect all the Kubernetes control plane elements, the masters, the etcd, and the worker nodes, and proxy, etc., and allows you to do things like scaling up and scaling down the number of worker loads and so on. And there's so that's a generic project. We implemented a provider implementation. that is specific to the IBM Cloud for this. Okay. Next chart. Okay. So hybrid applications are about workloads. So there's a GitHub project called Hybrid App IO, and there's a link to the documentation. And what this project does is to extend the notion of applications. It's based on the SIG app model that is in the Kubernetes ecosystem, but it extends it to being able to manage multi-component applications that span both Kubernetes resources as well as traditional VM resources. And in the future, looking at other types of resources from a cloud infrastructure. So if you want a application that has a managed database service that you want to leverage from the cloud, or a part of an application where you want to leverage a function as a service or a Lambda type of function, then you can integrate that. This is another area where we would like contributions from the open community and helping in driving the incubation of this project, so that we can integrate with other types of deployment models. So things like Ansible or PaaS layers and other clouds and so on. Currently, it provides a bridge between both container workloads and traditional VM workloads. And we'll be looking at extending the overall application model to cover day 2 operations of an application, things like monitoring and DR and backup and event management, etc. Okay. And let's switch to the next chart. And this is from a product perspective or an offering perspective. This is what we bring together a number of the open source projects, the hybrid app, the open cluster management, or the Red Hat advanced cluster management, as well as ManageIQ, to give a open standards-based management plane for hybrid applications, right? It's built on Kubernetes. It's trying to avoid any lock-in. It's built around a number of open source components, and it enables an ecosystem because it is based on Kubernetes, and Kubernetes is an open standard in the community. It allows other partners and other projects to plug in the areas of operational automation, application management, security and governance, and visibility, and so on. Okay, I won't go through all the other components that make up this product, but it leverages a lot and contributes to a lot of those ecosystem projects that you see in there. Okay, so let me talk about a couple of other projects that are specific to Kubernetes now. We can switch to the next chart. Right. We did make some contributions, and it's on GitHub around more advanced scheduling capabilities. So this is a project that tries to marry AI with scheduling capabilities. It uses learning-based algorithm, reinforcement learning algorithm, to allow you to detect certain problems that are kind of hard to do if you do a traditional algorithmic model. Things like pods always failing on a certain node. They can be, that can happen for a number of reasons. For example, the PVC is not bound, the NAS access on a node has been revoked, and the device plugins for GPUs are not configured properly. You can also have situations where placing a pod on a node will lead to poor performance, and there could be a variety of reasons that are listed there, whether CPU architecture or clock speed and so on. So rather than trying to come up with an algorithm that is very tied to those conditions, what we did is a scheduler extender that uses a reinforcement learning algorithm to adaptively learn where a particular type of workload is best placed based on the variety of conditions and based on learning from different failure modes and different cases of bad performance and so on. So the scheduler extender basically extends the Kubernetes scheduler to take into account the results of the AI algorithm, to direct the workloads to a particular node that best fits that set of conditions that might cause problems in terms of that. So it looks at the performance aspects, it looks at the availability aspects, and it tries to learn the behavior of workloads to be optimally placed. Okay, so this is a incubation project. Again, we were looking for feedback on that. Next chart. So this last project, again, the GitHub location is there. It's again around scheduling, but about multi-cluster, how to dispatch workloads from a central location to multiple Kubernetes clusters. And this addresses some of the challenges that people have, especially around managing batch type of workloads, complex workloads. So there's a notion of a app wrapper, which can wrap a variety of Kubernetes resources that gets scheduled or placed into this dispatcher running in a dispatcher cluster. And from there, they can be deployed out to different execution clusters, so different jobs or different deployments, and Kubernetes resources can be placed or scheduled onto different workloads. And this tries to address some of the gaps if one cluster is very busy because of bursty workload coming and going. This looks at available capacities for clusters, as well as energy awareness of the cluster's energy consumption and so on, and tries to make a intelligent decision about where to run these workloads. Okay, so that's it from my side. I think that's the overall talk. I don't know if there's any other charts, but okay. Any closing comments, Sahdev? So.
All right. Well, thank you. The closing comment is thank you, Khalid. Thank you, everyone, for watching this video. Reach out to us through Slack channel, through mailing list, various ways. If you have any question about this presentation, about the project, and we would like to have your participations in the SIG Cloud Provider, in the Provider IBM Cloud project. So look forward to work with you. And with that, Khalid, thanks again. Thanks, everyone. And,
thank you.
Yep. Thank you.